somewhat more detail. A range of options were considered in order to meet the navigational requirements or the regional requirements of IMO A915. The options on the left here were selected for further study. Option 1 considered procurement of a hardware replica of the existing system. The second option was similar to the existing system, except using software reference station rather than hardware equipment. The third option was software radio receiver and reference station and integrity monitor. Four versions of IGNOS derived service were considered. Each option was evaluated under headings along the top: backward compatibility, maturity of technology, flexibility for message upgrade, flexibility for future GNSS signals, and possible reduction in the infrastructure. The local concept evaluation looked at the possibility of providing high accuracy required for port operations to meet the requirements of A915. Because of the lack of support for the existing system, there was a short-term need to update the existing equipment so that the present requirements can continue to be met. This I'm terming the first generation options. There is also a longer-term need to adapt the system to future requirements, particularly modernized GPS. This I term the second generation. Some of the solutions in the first generation are clearly upgradable to meet the second generation requirements. Options such as full software radio receiver with software reference station and integrity monitor, beg your pardon, losing my place in the notes here. Options such as the full software radio receiver with software reference station and integrity monitor, as well as the space-based augmentation systems such as IGNOS, were also considered as part of the second generation. Having identified various technically available systems, an analysis of the overall functionality and architecture of each of the selected options was carried out. The first generation considered, our first question is, where is the processing carried out? The existing system is based on receiving, generating and transmitting corrections at each site. An alternative is to use a central processing station at which the corrections will be generated and then either broadcast from that station or sent to outstations for regional broadcast. The message generation process for each option was considered under the headings of data input, the source of the input data, method of generating corrections, and the method of transmission. It is essential that the integrity of the broadcast corrections is verified. This study then was taken forward to the next stage. Each option was evaluated in terms of the navigational performance required for accuracy, integrity, availability, and continuity. The assessment was carried out using the Nottingham Scientific Limited software tool NEMO. This provides a fully flexible platform for analyzing GNSS systems over a service volume at specific moments in time. In this table, along the top, low is for general navigation, medium is port operations as defined in IMO A915, while high is for high performance requirements such as docking and dredging. All of the code options in the first column met with the low accuracy requirement for general navigation. The medium accuracy requirements were met by the first generation code solutions for 95% of the time. The second generation requirement was also met by the software receiver and reference station integrity monitor for 95% of the time. The EGNOS solutions met the second generation requirements for 90% of the time. High accuracy requirements can only be met by the real-time kinematic solutions from either OSNet or the EGNOS Wide Area RTK. A risk assessment was carried out to identify critical functions, interfaces and elements that are essential to the DGNSS service to fulfill its requirements. The risk assessment also identified risks that may impact on the delivery or performance of the service, including technical, operational and political issues. Each option was subdivided into these 5 elements, and each element was then analysed to assess the risks. A risk was identified as anything that may impact on the timely delivery or reliable operation of the DGNSS service. This phase concluded that the option with the least risk for first generation recapitalization was the baseline hardware reference station and integrity monitor option. For update to the second generation recapitalization, the option with lowest risk was the software reference station and integrity monitor option, because it allows more flexibility to upgrade. The hardware computers are also available off the shelf. Initial capital costs for each of the options were estimated. For the first generation recapitalization, the baseline hardware RSIM option was the lowest cost, and the software RSIM option was next highest. The conclusion of the study was that the hardware RSIM option should be adopted as the first generation on the grounds of lowest cost and risk. Further study will be required to identify the longer-term needs of second generation DGNSS. Having selected the hardware RSIM option as the preferred option, the next stage was to seek tenders for this solution. Trinity House took the lead role as the contract entity for the 3 GLAs. Expressions of interest were invited under the EU European Journal procurement route, and expressions of interest were received from 8 potential suppliers. Following the issue of the invitation to tender, tenders were received from 2 vendors. Tender evaluation was carried out under these 4 headings: technical, program, financial and contractual. On the right, each of these criteria were weighted, with the technical criteria being the most important. The contract was awarded at the end of 2008. The program of work was drawn up to manage the development and installation of the network. The contract is a turnkey project for system design, testing, installation and commissioning of the system to meet our requirements. Factory acceptance tests are about to start, and completion of installation is expected at the end of this year.